put this thing in the medium, right? In the medium, this becomes F equals to 1 by 4 pi E, and then Q1, Q2 by R square, where this E is epsilon naught, and then not this K, but this kappa, right? Where this kappa is dielectric constant, and then this F medium, this becomes simply F air divided by this Q. So this is the Coulomb's law, and then we add equilibrium condition to it. So what does this equilibrium condition says? It will be of two types. One is that only one point is at equilibrium, right? And then there would be a system is at equilibrium, right? This shows that only at one point F net is zero, and this shows that at every point F net is zero, right? So this is at one point. And then after that, we have talked about tensions, right? So, and then we have talked about, we have connected this equilibrium point. So then we have connected this equilibrium with Coulomb's law, and then we added some tension to it, right? This is string tension, not the surface tension. So we have done some questions based on these ideas. We have done this kind of question that we have this string, and then two charges are separated by some distance d. And then we want to find out what is the equilibrium condition for this charge. Let's say Q. And there would be tension in this direction, there would be mg, and then there would be Coulomb force. So we have done these kind of questions. And after that, we have talked about the Coulomb's law in vector form. Right, so what does it say? So this is F12. This would be K Q1 Q2 R1 minus R2 vector divided by R1 minus R2 magnitude and Q. So these R1 and R2 are the position vectors. Right, so let's say if you have A, B, and C coordinate, so R1 would be AI hat plus BJ hat plus CK hat. So something like that. So we have done some question based on this. And then we have talked about superposition principle of force. So it says that the total force, net force, would be the sum of vector sum of the individual forces. So this we have done. And then we have talked about electric field, that is simply force per unit charge. And then we have calculated the electric field due to a point charge. So how much is this? Electric field at a point, this is simply KQ by R squared. And again, if we want to calculate the electric field due to multiple charges, so that also follows the superposition principle. E net would be E1 plus E2 plus En. So this would be the net electric field. And then we have talked about electric field due to a dipole. So there are two kinds of electric field. One is axial, and let me write it the vector part, and the other one is equatorial. So axial electric field is 2 kp by r cube. Equatorial is minus kp by r, where p is dipole moment. So these are the things we have studied so far. And then we have also talked about the electric field of a sphere. And this is a conducting sphere. So this will have two components. One would be E inside. This is 0, and then you have E outside. So this is kq by distance r square. So these are the things that we have studied. And the last part that we have studied was, so that was force on a charged particle in external electric field. So how much is that? So you have this electric field, and then you place a charged particle in here. Let's say this is positive charge particle. So electric field would be in this direction. Force would be in this direction. That would be QE. And let's say if you are putting a minus Q charge, so electric field would be, or force would be in this direction. Right? That would be minus Q. So all these things we have talked about. And then we have torque on a dipole in external electric field. So we have this electric field, and we put a dipole in here. This is minus Q, this is Q. This has a 2a distance. So this electric field, or the torque on this dipole would be, why this is not here? So this torque would be P cross E, right? And magnitude would be PE sine theta, right? So if sine theta is 90, torque is maximum. If this is 0 degree, then we have stable equilibrium. If we have 180 degrees, so that is unstable equilibrium, right? So theta is 90, torque is maximum, theta is 0 degree, then torque is stable equilibrium, minimum, and then theta is 180, then you have unstable equilibrium. So these are the different cases. So now let us do, these are the concepts that we have done in the previous class. So now let us do some questions which would be helpful, right? So what was the question that we were doing? So this is the last question that we did. We calculated the electric field due to many charges, right? And then we found out that this would be the electric. So now let us take one more question from here, and then we'll talk about. Yeah, this question is also important. So this question we will do, and then this one is also important. So both these questions we will get. This is not that important. So yeah, let's do this one, and then this one. So this would be, let's do this question first. So we have this thing, right? And we want to find out. So there are four charges placed, right? There are four charges placed, and we have to find out that direction of electric field at the center of the square along. So we have to find out in this question. There are 4 points, right? This is D, and this is 4Q. This is C, which is 3Q. This is A, which is Q, and then this is 2Q. So all four charges are there at the corner of a square, right? And then we have to find out, let's say this is the center, O point. We have to find out EO, right? So what would be EO? From superposition principle, we know that EO would be EA plus EB plus EC plus ED. So that would be EO, right? Now let us find out that at this point, due to this charge, what would be the direction of electric field? Can you tell me? Due to this charge, what would be the direction of electric field? Yes, can you tell what would be the direction of electric field? So, yes, this is a positive charge. So this would repel this thing, right?
Away from.
So away from this A point, so this would be AC direction, right? In here. So this is EA. Right, I have to pick. So this would be EA, right? Now I want to find out the electric field due to this 3Q, right? And we know that all these distances are same. So we know that all these distances, so this one is same, this one is same, this one is same, this one is same. So let's say this is L, this would be L, this would be L, this would be L, right? All these distances are same, and we know that electric field is KQ by R square. If this is fixed, then electric field is directly proportional to the amount of charge, right? So we have EA in this direction, and then we have EB or EC, that would be in this direction. Which would be greater, EA or EC? Which would be greater? Which electric?
EA.
So you see that EA has smaller charges, right? This one has bigger charge. So EC would be greater, right? Yes.
So EL has just one charge and EA has three charges, right?
No, no. So we are only talking about EA and EC. EC has 3Q charge, right? Amount of charge. We are talking about individual charges, right? We are
Yes,
not
sir.
we are not considering this D and B and A. So if let's say I want to find out electric field due to this Q charge at this O point, right?
Yeah.
So that would be EA only in this direction.
Okay. Yeah.
And then I want to find out electric field due to this C point, 3Q charge. So that would be away from it, right?
Yeah.
This is easy. And we know that the distance, this is fixed. AO, we know that AO is equal to OC, this is equal to DO, this is equal to OB. So these distances are fixed. And we know that electric field due to a single charge, right? That is how much? That is this thing, right? Is it clear?
Yes.
So if I write EA, that would be simply how much? EA would be KQ by L square. If I write EC, so that would be K 3Q by L square. So which one is greater? Which one is greater?
E EC.
EC, right? Because this is 3 times EA. So I can write it as 3 times EA, right? So EC is greater, so net electric field would be in this direction. So this is ECA, right? This part is done. So now we have counted EA and EC. This part is done. So final EO, this would be ECA and plus, let's find out these two contributions. So this would be due to this B point, the electric field would be in this direction, right? EB. And due to D, the electric field would be in this direction, ED. And again, we can say that ED would be greater, right? Because EB, this is simply K2Q divided by L square. And this is ED, this is K4Q divided by L square, right? So this is 2 times EB, right? So this would be, so the net electric field would be in this direction. That is EA, ED. Is it clear?
Yes, sir. It's clear.
Okay, now I want to find out the net electric field. So I have counted out these two things as well. And this would be EDA or DB. So this is the two contribution that will be added, right? And now I have to find out the electric field due to ECA and EDB. So I will make a parallelogram, right? And this would be the net electric field. So this would be EO. Is it clear? Is it clear?
Yes, sir.
So the direction is what? That would, I can say, D to A or C to B, right? This would be the direction, right?
Yes, sir.
So what is the correct option that we have? AB is not a correct option. CB is there. BD is not a correct option, right? And then AC. AC is also not a correct option. So this is the correct answer. Is it clear? Is it clear?
Yes, sir.
And if I ask you that what would be the magnitude of the electric field? So that would be simply EO magnitude, that would be simply EA square, not EA, but ECA square plus EDB square, because they are perpendicular to each other, right? This thing is perpendicular. So this thing is perpendicular. We are trying to find out the resultant of two vectors. So this would be simply the square of the z. So ECA, I already know what is ECA. That would be EC minus EA. So that is 2EA whole square. And then this is 2EB. So this is simply EB whole square. And I can find out the magnitude. So this would be the answer, right? So we in this question they're not asking the magnitudes, they are only asking the direction. So this would be the direction. Is it clear? And if it is clear, then just note it down. If you have any doubt, please let me know.
No, sir.
Okay, then please note this thing down, right? And then you can calculate the magnitude, right? So yeah, let's note this thing down. Whenever you have noted, just
Yes, sir.
yeah.
Done.
Okay, so now let us, and if they ask you the magnitude, right? So we can, yeah. So I have written vaguely, but we can solve this thing as well, right? So this would be simply how much? EA we already know. So EA is 4 and EA is how much? KQ. So K square Q square by L4 and then what is EB? So EB is K square and then 4 and then Q square divided by L. So 4, 4, 8. So this would be 8 K square Q square by L4. So the magnitude would be 2 root 2 KQ by L square. This would be the magnitude, right? So we can find the magnitude as well. But they have not asked for it, so yeah, let me move on now. And now let us do a different kind of question. So the next question is, this one is also right. So to get the net electric field at O, the 6E charge placed on the remaining 6 corners would be right. So this we can do, but yeah, let's do this question. So 14th one. So the 14th one uses the idea of, in the 14th one, we have to use the idea of force on a charged particle in external electric field, right? So what do we have? An electron falls from rest through a vertical distance h in a uniform and vertically upward directed electric field. So we have the external electric field, right? We have upward electric field, right? So this is upward electric field, and then the electron is falling vertically. So let's say this is electron. What is the charge on electron? Positive or negative? Yes.
Positive.
Charge on electron, electron.
Negative.
Negative,
Negative.
right? So this is minus. And now can you tell me what would be the direction of force on this electron? What would be the direction of force?
Same as that of the electron.
Same as the electric field. So let me just show you this diagram, right? So what have we learned so far? That if we have this electric field, if we put a positive charge, then the force is in this direction, right? That is QE. If I put a negative charge, then force is opposite to the direction of electric field, right? That is minus QE, right? So force would be in the opposite direction, right?
Yes.
So we have this negative charge, electric field is upward, so the force would be in the opposite direction. So force would be in this direction, right? This would be minus of E and then, E, right? Is it clear?
Yes.
So this is the force, and I can write this is the force on electron, and the magnitude is EE. So I can find out the acceleration of the electron. How much would be that? That would be, so I can write this force as mass into acceleration, mass of the electron and acceleration of the electron. This would be EE. So I can find out the acceleration of the electron, that is EE by m. Right. And the electron is falling from rest. So U is 0. And the distance that it is traveling is h. Right. So I can find out the relation between this h and this acceleration. So how can I write this thing? So S is ut plus half at square. U is 0, so this part cancels out. S is h, and then half acceleration is EE by ME, and then T is T square. Right. So this is the result. Now they are saying that the time of fall of the electron. Right. So time we have to calculate. This would be these two, and h and mass will multiply and then divided by the charge and the electric field. So we go. Right. So this is the time that I'm getting. Is this part clear? Yes. Is this part clear?
Yes.
Okay. So this is a case first. This is case for the electron. Right. Electron. Now in the second case, they are saying that now they are dropping a proton, but the electric field is reversed. So electric field is how much? So this is for proton, right? Electric field is reversed. So now this is the electric field, and proton is moving downwards. So what would be the direction of the force? Upward or downward? What would be the direction of force? Remember, proton is positive charge. What would be the
Down.
direction? Downwards. Absolutely correct. So this would be the force of experienced by the proton, right? So we will get the same acceleration and same thing. So the time that we will get, this is the electron time. So proton time we will get, that would be 2h mass of the proton divided by this E, right? Charge is same, electric field is same, height is same. All these three things are same. Only mass of the electron and proton are changed, right? So if I write the timing of these two things, so the time of the electron divided by time of the proton, this would be root of 2he, all these things will cancel, and this would be me by mp, right? And which mass is greater? Which mass is greater? Yes,
Mass of proton.
mass of proton is greater. So denominator is higher or larger. Denominator is larger, so this thing would be greater than 1 or less than 1.
Less than.
Less than. So I can write this thing as less than 1. So I can write that time of the electron would be less than time of the proton. So electron would be faster, proton would be slow, right? So what they are saying, that the time of fall of electron in comparison to the time of fall of proton is okay. So this should be time is, yeah, so time is faster meaning smaller, right? So electron will take smaller time. Is it clear? So this option would be correct. They would not be equal because that is dependent upon the mass. That would electron will is not taking greater time, right? Time is faster, so time is smaller. It will take smaller time for electron to cover this h distance, right? So electron will take a shorter time. So time of electron would be small. Is it clear for you?
Yes, sir.
Then quickly note this thing down and then we will, yeah, and then we'll do the next question. So this is the question based on force on a charged particle in external electron, right? So there is another question, but we have 45 minutes after that. Yeah, whenever you have noted just. So TE will take less time to cover distance H as compared to.
Done, sir.
Yeah. Okay, so now there is one more question like this. So I will just give you the idea. And that idea is that you have this, right, this space, and there is this electric field in downward direction, right? So this is a positive charge, and this is negative charge. So electric field in this direction, and then electron is provided some speed in here, right? So electron will experience a force in the opposite direction. So in this direction, the force would be there. And the electron is moving in this path, right? Electron is moving in this path and then proton is moving. Let's say proton is provided same initial speed in here and proton is moving in this path. So which will take lesser time cover this distance, right? So that is the idea. And you would be given that this length is L and this is H. So you have to calculate that which would take lesser time. Same idea. You have to apply the same idea, but this is a two-dimensional question, right? So you will have all these three equations, P equal to U plus AT and S equal to UT plus half AT square, and then you have V square minus U square is 2AS. But you will have two components. One would be X component and the other one would be Y component. So what would be the X component? X component would be the X distance and then UX speed and then Vx final speed and Ax acceleration, right? So this would be, and time for both the cases would be same, right? Vertical time, horizontal time, both will be same. Y component will have Y distance, Uy velocity, and Vy velocity and Ay acceleration. So can you tell me X distance is how much? This is L. UX is how much? Can you tell what is UX? What is UX? So this is the axis, right? This is X, this is Y. So what would be UX distance or UX velocity? So you are only providing in one direction, in this direction, initial velocity. So this is U, right? There is no vertical velocity. So UX is U. Vx we want to find out. AX. Do we have any acceleration in X direction? Yes. Any acceleration in X direction?
No.
No. So AX is 0. And again, Y is H. Uy is 0. Vy we want to find out. Ay is acceleration in vertical direction, right? So how much is Ay? So Ay it would be Ee by whatever mass do you have, right? How do we get this thing? So we know that F is QE, that is EE, and then F is MA. So this would be acceleration would be EE by M. So we know that force is in vertically upward or downward direction, right? So this would be the acceleration. This is EE by M. So we solve all these equation one by one, and then we'll get the time. Right? That is the idea of this question. Is this clear? Yes. So we have to follow the same process that we have applied in here, and then we can calculate the time. And then you see that this is dependent upon mass. So we'll get a mass factor, and then we can say that which would be cross this junction first. So whether it is proton and whether it is electron. So that is dependent upon the mass. So we'll again get some function which is dependent upon mass, and then you can say the answer, right? So that is the idea. Clear?
Yes.
Okay, so now this part is done. So the force on charged particle in external electric field is done. So now let us do some question on electric field over time, right? So let's do some question on electric field on a time. And this is, okay, this one is a very long question. So yeah, this you can do. But this is not due to a dipole. This is due to different charges, multiple charges, right? And that you can solve. So we have to find out the electric field at this you can try. Please try this question at your home, right? Please try this question at your home because this is a lengthy one and it will take time. So what is the idea that you have to apply in here? We want to find out EO. What would be the idea? Can you tell this? What would be the idea? I want to calculate the electric field at this point from A, B, C, where is C, C, D, E, F, G, H. So from all these contribution, I want to find out the electric. So what would be the idea? Yes. So the idea would be superposition principle, right? That would be EA, EB that we have applied, EC, ED, EF. That is a very long question, but you can try this question, and EH. So all these contribution we have to find out. We have to find out the direction, and please solve this one. And if you face any trouble, then please tell me. So just note down this, right? Let me zoom this thing. You just take the screenshot and please tell me the answer in the next. Right. So please solve this one. Just take the screenshot of this question. Okay, is it clear?
Yes, sir.
Yeah. So please solve this. Now let us move on to the next question, which is this one. So let's yeah, do this question. And there are direct question for this law, right? So for electric field due to dipole, these would be direct questions. So you have to just remember what is the electric field due to dipole at axial and at equatorial point, right? So the electric field at a point on the equatorial plane at a distance r from the center of a dipole having dipole moment p is given by where r is very greater than the separation of the charges, right? So you have a dipole minus q and then plus q. The dipole moment is in this direction, p vector, and we want to find out the electric field at r distance. This is r distance, so we want to find out the electric field at this point, right? What would be the electric? And we already know the result. So this is equatorial point, right? What is the electric field at the equatorial point? Yes, we have just done this. What is the electric field?
E is equals to K Q1.
So electric field due to dipole, electric field due to dipole. That thing we have just discussed, right?
2 DQ.
Yeah. So this is the electric, right? So at equatorial point, that is minus Kp by Rq. At axial point, this is 2 Kp by R, right? If it is unclear, then please tell me, right? So do you remember what is the axial and equatorial point? Do you remember that? Yes, please tell me. If you have any confusion, please tell me, right? Don't keep the confusion to yourself.
AQ by R's.
So, okay, so let me just, yeah. So we have this equatorial point, we have this axial point, right? So at axial point, this is 2 Kp by Rq. At equatorial point, that is minus Kp by R. That is that is the electric field due to a dipole, right? So this would be how much? At equatorial point, that is Kp by R, right? So this is how much? K is 1 by 4 pi epsilon naught and then R. So this would be the electric field at equatorial. So what is the correct option? Uh, Minus Kp by, right? Is it clear? So you see that this was a direct question. It is a direct question and that will give. We have just remembered these two things, right? So at axial point, right? And what is the axial and equatorial point that we have to understand? So in the same line, right? In the same line, this is the axial point. So if you have the same line, if you're calculating the electric field at the same line, so that would be axial point. If you are calculating the electric field at perpendicular direction, so that would be equatorial, right? And this is axial, this is equatorial. So just note down this thing and then we'll do the next question. Okay, note down this thing. So you see that this was a direct question, right? So we have just remembered two results from the dipole. Yes, noted.
Just a second, I'm writing the question.
Oh, yeah. What is connected? Yes, Iram, you got it correct. Right.
Yes, sir. I have some issue.
Yeah. No. Okay, so yeah. Uh, did you note down this part? This part.
Yes, sir, I do.
Okay, so now let us do some other questions, right? This was let's orally, right? Let's orally do all these questions, right? So we don't need to note all these things now. But one question we will do, but before that, let's orally do all these questions, right? So these are very direct questions, right? You can see that you can find the answer pretty quick, right? So these are two direct questions. So this 27th one, intensity of an electric field depends on distance r due to the dipole is related as. So how for both the cases, how electric field varies? Do you remember? For for a dipole, how the electric field varies?
E is inversely proportional to R square.
R square. Okay, so if we remember for axial, this was Kp 2 Kp by Rq. For equatorial, this was Kp by Rq.
Oh yeah, R cube, yes.
So this is varying as 1 over R, right? For both the cases. So this is the correct. So you see that this is a direct question, right? So from electric charges and fields, they will ask you direct questions, right? And similarly, this question is similar, right? So Q on the perpendicular bisector. So this is a point Q on the perpendicular bisector of a dipole, right? And then what is the electric field at Q? So we know that this is minus Kp by R cube. So this is Kp by R cube if we ignore the minus sign, right? So do you remember why this is a minus sign? Yeah, I will talk about that later, but let's talk about the answer for this question. So EQ is directly proportional to P and EQ is directly proportional to 1 over R. So this would be the correct option, right? Is it clear?
Yes.
Okay, so now we will do this next question, and this will take some calculation, right? So now let's do this question. And I will also talk about why there is a minus, right? Okay, so we'll do this question at some point, but first let us talk about why there is a minus, right? So we have a dipole, and we know that what is the direction of dipole from minus q to plus q. So that is the direction of dipole, right? And if this is the center point, and if we want to find out the electric field at equatorial point, right? So this is minus Kp by Rq. And if I want to find out the electric field at the axial, right? So E axial, this is 2 Kp by R. And you know that this P is dipole moment. This is equal to the charge and the separation. Let's say separation is D and then P hat. So this is the dipole. So the electric field at the equatorial point, that is in the opposite direction of the dipole. That is why you have this minus. And the electric field at the axial point, that is in the direction of dipole moment. So that is why you have this positive. So is it clear? Is it clear?
Yes.
Okay, so keeping that in mind, let us find out. So 3 point charges plus q minus 2q and q are placed at points respectively. The magnitude and direction of the electric dipole moment vector of these charges assembly or this charge assembly. So we have, let's say we have this coordinates, right? So let's write this as x, y, and z, right? So we have x0, ya, and z0. So at this point, right, x0, z0, so that is y-axis. So at y-axis at a distance, this is a distance and this point is 0, a 0. You have a plus q charge, right? So at this point you have a plus q charge and 0, 0, 0. So that is origin. At origin, you have minus 2q charge, right? And then x equals to a, y0, z0. So at x-axis at a distance away from it, so this is a distance. And then you have another charge. This point is, this is a 0, 0. And the charge is how much? Charge is again plus q. So what you can do is that you can break this minus 2q as minus q and minus q. So you will have a dipole in this minus q and plus q. And the separation is this, right? So this is one dipole. Plus you have another dipole which is in this way. Minus q and plus q in the x direction and a distance. So these are the two dipoles, right? One is in this direction and the other one is in this direction. Right? So let's say this is P1 dipole moment. This is P2 dipole, right? Is it clear?
Yes.
So now we can find out what is P1. P1 is simply the charge which is Q and separation which is A. So AQ, and what would be the direction? Can you tell me what is the direction in IJK hat form? What is the direction? Yes. What would be the direction? What would be the direction of this P1 dipole? Going upwards. So that is here.
Yes.
And if I want to find out P2, so that is separation, which is A, charge. And what would be the direction?
I. I.
I have, right? Absolutely correct. So this is the direction. So now I have to find out the resultant of these two vectors, right? So resultant would be simply P1 plus P2. So this is AQ, and I can write J plus I hat. So this is I hat plus J, right? So this is the resultant. AQ I hat plus AQ J hat. So what would be the magnitude of this vector? Magnitude would be simply root of AQ square plus AQ square. So this is 2AQ square. So this is root 2AQ. This is the magnitude, and direction would be how much? Tan theta is AY upon AX. So AY is AQ. AX is AQ. This cancels and this is 1, so theta would be 45. So this would be the answer. Is this part clear?
Yes, sir.
Okay, then please note down this part. So the resultant would be this direction, right? So this would be the resultant, and this is right, and this angle would be 45 degrees. We know that this is making 45-degree angle with x axis, and magnitude is this. Magnitude is this one. This is the direction. Please note this thing down, and then we will do the if 10 minutes. Whenever you have completed it down, whenever you have this one is the direction dipole moment would be one. This one is the direction dipole minus q.
Yes, sir.
Then, okay, so the next topic is, so now this part is done, and the next topic, force on a charged particle we have done, right? So these things we have done. Now, let us talk about flux and Gauss, right? So in the flux and Gauss law, what have you learned? That flux is, right? So what is an electric flux? That is denoted by phi, and I can write this as phi. So this is electric flux, and this is how much?
It's total charge enclosed by the surface.
Total charge infused by the surface. Yeah, so that you can say. And this is also defined as,
E dot ds.
yeah, so number of electric field lines passing normally through the surface. Right. So if we have this closed surface, and let's say we have this thing, right? So this is coming in and this is going out, this is coming in and this is going out, this is coming in and this is going out. So for this case, what would be the number of electric field lines? Or what would be the flux? That would be zero, right? Because three or how many numbers? One, two, three. And yeah, three now, three electric field lines are going inwards and three are coming outwards. So that would be 3 minus 3, which would be so number of electric field lines passing through, normally passing through the cell. And as you say, there is another formula which is E dot ds, right? So this is for a small or curved surface. But if we have a plane surface, so for plane surface, this is simply E dot A. Plane surface meaning that let's say we have this kind of surface. So this is a plane surface. Then for this surface, and the flux is simply E dot E. But if you have a closed surface, so for this thing you take a small area element and then you calculate the number of electric field lines passing. So this phi is simply E dot ds, right? And in a closed integral, in a closed loop, this is simply, as you have said, Q enclosed by epsilon. So this is what we call the Gauss loop, right? So in a closed loop, the flux would be simply charge enclosed by epsilon. So this is a very important thing. This is called closed, right? So that surface should be closed. If that is an open surface, then that would be a different scenario, right? That would not be equal to Q enclosed by epsilon. So this is the flux that is defined, and then this is the Gauss law, and then we apply this Gauss law, right? So we apply this Gauss law to find out. So we find out the electric field Q or linear charge density. So let's say you have this wire and this has this charge. So for this linear charge density, it has, let's say, lambda as linear charge density, Q by L. This is the linear charge density. And for this electric field at a certain point, let's say at this point, this would be lambda by 2 pi epsilon naught r. So this is the electric field of a linear charge type, where lambda is linear charge density, which is Q by, right? And then we calculate the electric field of a sheet. Electric field of a sheet. And how much is the electric field? This is sigma by 2 epsilon, right? And let's say, so if we have this sheet, and let's say this is a positive sheet, so electric field would be outwards, and in both the direction, this would be sigma by 2 epsilon, right? Is it clear? And where this sigma is the surface charge density. And what is that? What would be this surface charge density? Can you tell me? Yes. Linear charge density is Q by L. So what would be surface charge density? So linear had this length. Surface is area. So that would be Q by E, right? And then there would be volumetric charge densities that would be Q by V. So these are different right electric fields. And we have already talked about electric field of conducting solid sphere or non-conducting hollow sphere or conducting hollow sphere. So for all these three cases, the electric field E inside, that is 0, E outside, that is KQ by R. So for all these three cases, we have right. So if you have a sphere and if it is conducting, so all the charges would be at the surface. If it is hollow, then all the charges would be at the surface. If it is non-conducting hollow, so all the charges would be at the surface. So for all these three cases, the charges are at the surface. E inside would be 0, E outside would be KQ by R. Right. So these are the things that we need to remember, and then we will do some question based on this, right? So next class, we will use all these ideas and then we'll do question, right? So have you noted down these parts or do you remember all these things? We have already learned these things, right? Yes. Any doubt from these concepts? Yes. Any doubts that you have? Hiram? Yeah, I cannot hear you. So are you saying something? Okay, so yeah, we'll stop here and then, okay, so no doubts. Then we'll stop here and there are different questions that I wanted to do. Don't have that much of a time. So these are different questions, right? And we'll do all these questions in the next. So yeah, these will not take that much of a time and we'll do all these questions in the next class.